Hi guys, welcome to the 7.5 exponential growth and decay video. In this video, I'm going to show you how exponential functions can either grow exponentially over time or decay, and how to identify which one it is. So first, exponential growth occurs when a quantity increases by the same rate over time. And we're going to use the formula below is y equals a times quantity 1 plus r to the t exponent. A stands for the original amount. R stands for the rate, and you have to convert that as a decimal. And T stands for time. So let's take a look at an example. The original value of an investment is $1,400, and the value increases at 9% each year. So that's telling you the initial amount was A, and the rate was 9%. So we have to convert that to a decimal. Write in an exponential growth function to model this situation. Then find the value of the investment after 25 years. All right, so we have A, which is 1,400. We have R, which is our 9%, and we have T, which is 25. So when we plug that in, we have 1,400 goes where A is, then we have parentheses 1 plus the rate. And if you think of 9% as pennies, how would you write down that you have 9 pennies? And it would be 0.09. And then we're going to raise that to the 25th power, and that's because we have to find what it will be after 25 years. So in your calculator, depending on which kind of calculator you're using, there's 3 different ways you can find this answer. So you can either use the caret, which looks like an upside down V. You can use the X to the Y button if you're using your cell phone turned sideways. And if you have the Texas Instrument X30A, then you're going to use the button that has Y to the X, which is located above the division button on your calculator to the right. So depending on which one you use, that's what you're going to plug in. So you have to do the exponent first and then multiply it by 1,400. And when you do that for this, it would equal $12,072.31. All right, let's take a look at number 2. So the cost of tuition at a college is $12,000, which is your A, and it's increasing at a rate of 6%. So we're going to convert that to 0.06. Write an exponential growth function to model the situation, then find the tuition after 4 years. So that's your T. So we set up y equals 12,000 times 1 plus 0.06 to the 4th power. When we add 1 plus 0.06, you get 1.06. And then when you raise that to the 4th power and times it by 12,000, your answer is $15,149.72. Okay, so for number 3, the number of student athletes at a high school is 300 and is increasing at a rate of 8% per year. So what we can do with that is we know 300 would be A, or the original amount, and 8% we can convert to 0.08. And then we have to write an exponential function that will model this situation and then find out how many athletes there will be after 5 years. So 5 is our T. And that's a really bad T, Mrs. Glenn. I'll change that in a second. All right, so A we're going to put in as 300. Then we do 1 plus our 0.08, raise it to the 5th power. Then when we rewrite that, we would add 1 and 0.08 together. And in your calculator, do 1.08 to the 5th power. Hit equals, and then times it by 300. So you're going to have approximately 441 athletes. So in this situation, we can round up because this is exponentially predicting what's going to happen. It's not an actual amount. So there's a difference between, like, if you have a certain amount of money and you want to bring your friends to the movie theaters, you can only bring in 10 friends if you have such and such amount of money. This situation is kind of guessing how many they're going to have after 5 years. So it's not an actual definitive amount unless you actually in 5 years see how many athletes they have. So we can round up in this situation with exponential functions. Number 4, annual sales for a company are $149,999 and are increasing at a rate of 6% per year. Write an exponential function to model the situation and then find how much the annual sales will be after 7 years. So we know 149,999 is our A, 6% will be 0.06, and then we're going to find it after 7 years, so that's our T. And if you notice, I write the T as a cursive T because we don't want to make it look like a plus sign. So we could show a difference between a T and a plus sign. So kind of make it have a little bit of a tail, and then we can make sure we don't use it as a plus sign. All right, so we're plugging in A, and then we'll put in our R, which is 0.06, and raise it to the 7th power. We're going to add our 1 and our 0.06, and then we're going to put in our calculator 1.06 to the 7th power, hit equals, and then times it by 149,999, and you're going to get $225,543.04. So that's how much money you will have that's how much annual sales they will have after 7 years. Number 5, a population of a small town is 1,600 and it's growing at a 3% rate. We have to write the function and then find how much the population will be after 10 years. So A is our 1,600. That's the amount of people that lived in the town originally. And then it's increasing at 3%, which is 0.03. And our T is our time. So we plug in 1,600 where A is. And then we plug 0.03 where R should be going. And then 10 is our T. Add 1 and 0.03 together and you get 1.03. Raise 1.03 to the 10th power and then hit equals and times it by 1,600. And you get approximately 2,150 people. All right, for number 6, I want you guys to do that one on your own. So you need to underline and identify your A, your R, and your T, and then plug them in, add the 1 with the R, and then raise it to the exponent and times it by the A in front. And for this situation, we're talking about subscribers, so again, you're going to round because it's just an estimate. Okay, now we're talking about exponential decay. So occurs when a quantity is decreasing. So D for decay, D for decreasing by the same rate over time. And our A, R, and T are going to be the same thing. Our original amount, our rate as a decimal, and T as time. So let's take a look at a couple of examples. Population of a town is decreasing at a rate of 1% per year. So that means people are moving at a rate of 1% per year. So we can convert that to 0.01. In 2000, there were 1,300 people. So that's our original amount. Write an exponential decay function to model the situation, then find the population in 2008. So if you were struggling to find the answer to number 6, this might help you find that answer. And if you have me on mute, you might not help or get the help that you need to be able to answer number 6. However, if you take a look at that, it tells you in 2000 that there are 1,300 people, and we need to find how many people there will be in 2008. Well, that's a difference of 8 years. So we can use 8 for T. So we plug in A is 1,300. We have our rate, which is 0.01. And for T, we're going to use the number 8 because they're going to ask us from the year 2000 to the year 2008, which is 8 years, what will the population of that town be? So we plug in 8. We subtract 0.01 from 1, which is 0.99. Raise that to the 8th power. So 0.99, your exponential button, hit and then 8 and then equals, times that by 1,300. And if you notice something, that parentheses is less than 1 now. So that immediately actually can tell you whether or not an exponential function is growing or decaying based on the b value. Remember, our original equation is f of x equals a times b to the x power. So when a is 1, then that's your y-intercept on a graph. And when b, which is the parentheses, is less than 1, it's decaying. Because if you think about it, if you're multiplying by a decimal, your numbers are going to get smaller. If you're multiplying by a number bigger than 1, your numbers are going to get bigger. For example, 100 times 1.5 is 150, which is larger than what you started with 100. But if you multiply 100 by 0.5, then you're going to have 50. And 50 is half of what you started with. So if it's less than 1, it's decaying. If it's greater than 1 inside that parentheses, it's growing. So if they ask you a question, is this growing or decaying, and they just give you the function, you can tell by the parentheses. All right, so let's calculate this. And when you put 0.99 to the 8th power, hit equals, times it by 1,300, you get approximately 1,200 people. So they had 1,300, and in 8 years, they lost 100 people. Number 8, a car is depreciating, which means the value of it is going down. It started out at $18,000 when you bought it. It's depreciating by 12% each year. So A is 18,000, 12% we can convert to 0.12. And we need to find out how much the car is going to be worth after T, or 10 years. So we plug in A is 18,000. The R will be 0.12, and this is depreciating, which means it's going down. So we do 1 minus the R instead of 1 plus the R. And then T is 10. So 1 minus 0.12 is 0.88. Raise that to the 10th power. I don't know why that says 1, because that's not right. Raise that to the 10th power. I just want to make sure my calculation is right in here. Times 18,000 after you find the exponent. And you get approximately $5,013.02. So the car, when you originally bought it, was $18,000. After 10 years, it'll only be worth $5,013.02. All right, number 9, a farmer buys a tractor for $50,000. If the tractor depreciates at 10% per year, write an exponential decay function to find the value of the tractor after 7 years. So A is our $50,000. 10% we can convert to 0.10, and T is going to be that 7 years. So we have Y equals our $50,000 times parentheses 1 minus the 0.10 raised to the 7th power. 1 minus 0.10 is 0.90. Then we put 0.90 into our calculator, raise it to the 7th power, hit equals, and times it by 50,000. And you get $23,914.85. So it's actually going to be worth less than half that you paid after 7 years. So everything depreciates in value as soon as you take it home. Just remember that, everybody. All right, number 10, an investment of $8,200 loses value at a rate of 2% per year. Write an exponential decay function to find the value of the investment after 9 years. So remember, our exponential formula is y equals a times parentheses 1 minus r quantity to the t power. So we have to find a, which is 8,200, and then 2% can convert to 0.02, and 9 will be our t. So we plug that in where it goes. 8,200 is where a is, and 0.02 is r, and t is 9. Subtract 1 minus 0.02, and you get 0.98. Raise that 0.98 to the 9th power, hit equals, times it by 8,200, and you get approximately $6,836.73. The investment will be that much after 9 years. Number 11, we bought a book for $58. It decreases as a rate of 7% per year. Write an exponential decay function and find how much the book will be valued after 8 years. All right, so A is our $58 that we paid originally. 7% will be converted to 0.07, and 8 will be T. So we plug that in where it goes, subtract 0.07 from 1, get 0.93, raise it to the 8th power, and times it by 58. So the book will be worth $32.46 when you round up to after 8 years. For number 12, I want you to do that on your own. But take a look at number 12. Number 12 is similar to the problem that I had you do originally for the growth one, where you had to calculate the difference from a year to another year. So this is from 2000 to 2015. So just remember, T would stand for the number of years between 2000 and 2015. Good luck. Go Seahawks. Woo!